Today we're reviewing everything from lessons 5.1 through 5.4, which covers rates, ratios, equivalent ratios, ratio tables, and unit rate. In this first example, we're asked to write the ratio of cans of cola to cups of coffee. When you write a ratio, you want to identify how many there are of each item. So because there are 4 cans of cola and there are 1, 2, 3, 4, 5 cups of coffee, we're going to write that ratio in the order it's provided. So it's cans of cola to cups of coffee. So the ratio will be 4 to 5, or you could use the words 4 to 5. Now, ratios can be written in a format that looks like a fraction, but as you can see, that could be very misleading to someone who's unsure because the ratio 4 to 5 written with the fraction bar looks like it means 4 out of 5, when in actuality, if we'd written the ratio of cans of cola to total beverages, that ratio will be 4 to 9. So we've got to be really, really careful, and we want to probably avoid doing this until we are more comfortable with ratios. Here's an example of a ratio table. We're asked to find the missing value in the table and then write the equivalent ratio. We need to be careful with a ratio table because all we're doing is organizing ratios. It doesn't necessarily mean that there's a pattern across because we're not listing like a table of values. So for example, in this relationship, the ratio of trucks to cars is 2 for every 3 cars. There's 2 trucks for every 3 cars. So to complete the table, we want to make a connection here. We can see that 2 times 3 equals 6. So we want that same connection to go from box 1 to box 2 here. So we're going to multiply 3 times 3 to get 9. Now that same relationship can be made between the 3 and the 27. And you can see 3 times 9 is 27. So we need to multiply 2 times 9 to get 18 for the missing value here. So this shows 3 equivalent ratios. The ratio of trucks to cars can be 2 to 3, 6 to 9, or 18 to 27. So when we're asked to write the 3 equivalent ratios, we would write 2 to 3, 6 to 9, 18 to 27. We'll do one more example here. And you can see we're now doing the ratio of lions to tigers, perhaps at different zoos. So the ratio of lions to tigers is 10 to 2. So since we're clearly dividing 10 divided by 2 to get 5, we would need to divide the 2 divided by 2 to get 1. Since we're clearly multiplying 2 times 6 to get 12, we multiply 10 times 6 to get 60. So the 3 ratios we're looking at are 10 to 2, 5 to 1, and 60 to 12. Note again, this isn't a pattern going left to right. It's the relationship between lions and tigers, and that relationship must be consistent. A great way to help to illustrate ratios is to use what's known as a tape diagram. It's called a tape diagram because it looks like small pieces of tape. And it's good for comparing, rather than trying to draw a bunch of players to compare, you draw the rectangles, which are easy to duplicate. So this question reads, there are 40 players trying out for the baseball team. The ratio of infielders to outfielders is 5 to 3. How many outfielders attended the tryout? Well, because there are 40 players, you can see that this ratio of infielders to outfielders is 5 to 3. Well, that's a total of 8 here in the tape diagram. And so that 8 is the term we're interested in working with, because if we divide the 40 total players divided by the 8 pieces of tape that represent the ratio, you find that each piece of tape is valued at 5 players. So I can put a little 5 inside each of these pieces of tape and then very simply answer the question, how many outfielders attended the tryout? Well, it's 5, 10, 15. So 15 outfielders. Now, if the different question was asked, how many infielders attended, you could clearly determine that 25 infielders attended the tryout. This is another good way of comparing ratios and rates, and this is known as a double number line. And the double number line shows the 2 different categories. So this is showing cans and kilograms, okay? And so, maybe the weight of the cans is shown here. So for every 2 cans, it's 5 kilograms. For every 4 cans, it's 10 kilograms. For every 6 cans, it's 15 kilograms. So any one of these numbers, these comparisons, can be used to represent this ratio because these are equivalent. So they're continuing to grow. These are continuing to grow at their rate. And so you can clearly see in any place the rate that represents the situation. You could also do some estimation here and know if 7 was to go here, whatever answer is directly between 15 and 20 would be the weight of 7 cans. So if you were to find the average of those two, or if you just knew that 17.5 came between those, that's how you could determine the missing value. So that's a great way to organize your information. Now, a speed limit, is an example of a ratio that uses two different units. So rather than comparing cars to trucks or boys to girls, you're comparing specifically this speed limit is 20 mph, which stands for miles per hour, and your two units are miles and hour. And so you're comparing a distance and time. And so that's what makes this a ratio. Now, 20 miles per hour is actually a unit rate because this particular rate shows that in 1 hour you can go 20 miles. So a unit rate shows two different terms where one is one of your terms. Unit rate is very valuable. For example, if you go to a grocery store and you want to buy some oatmeal, and you could buy it in single serving containers, you could buy a box that has several single serving packets, or you could buy a cylinder of oatmeal. To determine which is your best buy for your money, you'd want to determine the unit rate. Now, unit rate is actually listed right on the price tag. So, for example, if you're comparing something that costs maybe $3.50, but up here in the unit rate, it tells you it's 11 cents per ounce. Something else might cost $4.30, but the unit rate up here might say that it's 13 cents per ounce. In another scenario, maybe something is less expensive, only $2, but the unit rate might be more. And so the unit rate is comparing how much something costs per ounce, and so or per pound or per 100, and it will be very clearly listed on there. Unit rate can be calculated by taking the cost and dividing it by however many ounces or pounds are in the item. Here's an example of how we could figure out unit rate. So if there are 105 pretzels in 5 bowls, we want to know how many pretzels are in 1 bowl. And we could do that. We could write our rate in fraction form, and we basically just divide, because what we're essentially doing is writing an equivalent ratio with 1 as the second term. Since you would divide this by 5 to get 1, you divide this by 5 to get your missing number. What we've learned, though, is if you just divide this by this, it will give you this amount. So 105 divided by 5 is 21. So there are 21 pretzels in 1 bowl. Now to do the same thing here, since 72 divided by 9 is 8, it will be 8 pictures in 1 frame. And the same thing here, 175 divided by 7 would be 25 papers in 1 paper clip. Notice when it's a unit rate, a 1 is always going to be a term. Now here's an example where unit rate could help you to solve a problem. You know that 5 hamburgers cost $11. You want to know how much it costs for just 2 hamburgers. So by finding the unit rate, finding out how much it costs for just 1 hamburger by dividing 11 divided by 5, you find that 1 burger costs $2.20. Now, since we want 2 of them, we would simply multiply that by 2, and we'd find out that 2 hamburgers cost $4.40. So again, by dividing to find out how much it costs for just 1, then you can multiply by 2 to find out how much it costs for the 2. The last example is when comparing items, as we had explained in the grocery store. So you could buy 12 ounces of cereal for $3 or 20 ounces of cereal for $4.50. To determine the better buy, you'd actually need to divide both of these. So if we divide $3 by 12, we find that it costs 25 cents for 1 ounce. So the 12-ounce container is 0.25 for 1 ounce. Now, the second container, $4.50 for 20 ounces, you can actually see that even though it's got a 2 and a 5, this 0.225 means 22.5 cents per ounce. So if I wanted to place a 0 here to make it easier to compare 0.250 or 0.225, even if you round this to 23 cents, it's clear that the 20-ounce box is the better buy because it costs less. Remember, when you're buying things at the market, if they're the same item, but you can buy that item for less amount per ounce, that's going to be the better price. Thank you for sticking around during this very long video. I appreciate it. Take care.